Okay. All right. If you were integrating over a region B that is a rectangular box, where this says your x's range from A to B, is what this says. This one says your y's range from C to D. And this one says that your z's range from R to S. Then the triple integral over that region B can be set up in any order because these are all numbers. So you could go from A to B, from C to D, from R to S, your function in x, y, z. This is dz, this is dy, and this is dx. When you calculate this integral, it should make sense that this is an iterated integral. You do it from the inside out, just like you did with two variables. Right? Again, because these are numbers, this can be set up in any order. You could flip it around and you'll get the same answer. Does that make sense? You could put this, you could put R to S out here, you could put A to B in here, and you could put C to D here. Your function x, y, z. This is dy, this one is dx, and this one is dz. It doesn't matter, you're going to get the same answer, but you always calculate from inside out. That doesn't change. I mean, if you had a function of 4 variables, you could have 4 integrals. Function of 5 variables, you could have 5 integrals. And the process is the same. Okay, inside to outside. All right, as long as they're all set up with nice numbers, the order doesn't matter. All right, when your general region is not just a box, if you're integrating over a region E, let's say, that consists of ordered triples, x, y, and z, your x and y is over an area D that's in your xy plane. This would be D in your xy plane. But your z's range between functions. Say the z limits are functions. Then you have to change your triple integral. You have to make sure that this integral is on the inside, because these would be functions of x and y. So that has to be on the inside, and then you can do your x and y in any order. Okay, so if your limits of integration or variables, that goes on the inside. And then you do your x and y. Now I'm just writing this out, I'm doing this, and then I'm going to show you some examples that use all this, okay? All right. If your region E is such that your x's go from A to B, but your y's go between functions of x, and your z's go between functions of x and y, then your triple integral over your region E of x, y, z, dv has got to be set up so that your z's are on the inside. So you want the a's to be on the outside. You want your y's, which go from g sub 1 of x to g sub 2 of x. Then your z's have got to be on the inside. And your function of x, y, z. This is your dz, this is your dy, and this is your dx. There is a very certain order. Order matters. All right, I don't know if you've noticed. You're so busy writing, I know. But the limits of integration that have x's and y's have got to be on the inside. Then your limits with x's, and then your numbers. So the most variables go on the inside, if that makes sense. And another example your book gave, if the region E was such that y ranged from C to D, but your x's went between functions of y and your z's were between functions of x and y, then the y is going to go on the outside. So this integral would have C to D on the outside, h1 of y, h2 of y, u1 of x and y, u2 of x and y, your function of x, y, z. This one is the dz, this one is the dx, and this is the dy. Again, order matters. Before I work any problems, do you have any general kind of questions? No, I'll stop while you're still copying. Okay, I will say while you're writing, you are going to have to draw pictures of your region, usually the XY plane, to get your regions of integration, your limits of integration for your X and your Y. You've got to do that. I'm still writing. I'm going to work problem 9 out of your book, so if you're finished copying this, you can look at problem 9. Okay, number 9 says we are going to look at triple integral over the region E, the function y dv, and E is a set of ordered triples such that x's go from 0 to 3. Your y's are going from 0 to x. And your z's are going from x minus y to x plus y. Okay, in this particular problem, you do not have to draw a picture because they gave you your limits of integration. All you have to do is set it up and integrate it. When you set this one up, the limits for the z have got x's and y's. That's got to be the first one you evaluate. This one has got to be the second one, and you've got to end with your x's. So when you set up your triple integral, it's from 0 to 3 on the outside, 0 to x next. On the very inside, you have to have x minus y to x plus y, and you're integrating y, first with respect to z, then with respect to y, then with respect to x. Now, do you want me to do this one by hand, or can we do this with a calculator? We can do this with a calculator. All right, I want to make sure everybody can put it in there and get the right answer. So just humor me and put it in your calculators, please. Pardon? Oh, okay. And then I hope I'm going to type it in right. Okay, if I typed it in right, I got 27 over 2. So that means y'all should get 27 over 2. Okay. All right, so that's a kind of easy one. Okay. Then we can skip down here to number 15, where they want the triple integral over a region T of y squared dv, where T is a solid tetrahedron with vertices 0, 0, 0, 2, 0, 0, 0, 2, 0, and 0, 0, 2. All right, you need to plot this in 3 dimensions, and you're probably going to have to plot it in 2 dimensions also. Okay? So let me say, I'm going to start by looking at 3. This is my x, this is my y, this is my z. I know I need some 2's. So 0, 0, 0. 2, 0, 0 is right here. 0, 2, 0 is right there. And then 0, 0, 2 is right here. So here would be my tetrahedron. This is the top of my tetrahedron right here. In this particular shape, they do not give you any of your limits of integration. Not with z, not with x, not with y. This, if you can imagine it, if you come out here, it's like having, if you go out to here, and up to here, and you connect all those, you've got like a tent, or half of a tent. And this is your top, okay, the top of the tent. You have to find an equation for that to get your limits for z, okay? Then you also have to look down here in your xy plane to get your limits of integration for your x and your y. All right, so I'm going to go to the xy plane first, and then I'm going to go and worry about the top of this thing. So this is what it looks like in 3 dimensions. Now you need to go and look at it in your xy plane. When you look at the xy plane, you plot the first 2 points of each of these. So I need the point 0, 0, which is right here. The point 2, 0, right here. And then the point 0, 2 is right here, and then the point 0, 0. So in the xy plane, this is my shape. I've got a rectangle. Are y'all with me? That's not a rectangle. Yeah, that would be a triangle. Today it's a triangle. It's close. It's half of a rectangle. Okay, so you got to find your limits of integration. I like to go with my y's this way, so I've got to find the equation of this line right here. And that line is y equals, is it negative x plus 2? Is that what you said? Okay. So that means my y's, and I advise you to write all this down. Write what your y's go from. They go from 0 to negative x plus 2, from the bottom to the top. Your x's, write down what they go from. That's going to go from 0 to 2. So you've got your x's and your y's now. Okay? Now you got to go over here and get your z's. This thing right here, I told you it's like a plane. In fact, it is a plane. So guess what you have to do? Find the equation of this plane. So this goes back a couple of chapters to the equation of the plane. You have got to have a vector that is perpendicular to this plane and a point. All right, so I would choose this as my point. That is the point when I plotted it of 0, 0, 2. And from that point, I'm going to get me 2 vectors that I can do the cross product of to get me the orthogonal vector. Are you following me? All right, so this vector, this point right here is the point 2, 0, 0, and this one was the point 0, 2, 0. So I need some vectors. Vector 1, I guess I would subtract here. That would give me the vector 0, 2, negative 2. That's my vector 1. My vector 2 is going to be over here. I'm going to have two vectors that are in the plane. This vector is 2, 0, negative 2. You've got to have two vectors in the plane. Now do the IJK. 0, 2, negative 2, 2, 0. To get a vector that is orthogonal to that one. Negative 4 minus j, 0 minus a negative 4 is plus 4. K minus 4. So that is going to give me the vector negative 4, negative 4, negative 4. And this is my normal vector. I'm doing all this to get the equation of the plane. So now that I've got my normal vector, this was the point that was in common to both of them. So the equation of the plane is negative 4 times x minus 0 minus 4 times y minus 0 minus 4 times z minus 2 equal to 0. Negative 4x minus 4y minus 4z plus 8 is equal to 0. So 4x plus 4y plus 4z is equal to 8. That's the equation of the plane. That's right there. So my z's, if y'all are with me, this plane out here, my z's are going from this xy circus to this plane. So I'm going from 0 to this plane. So I need to solve this for z. So z is negative x minus y plus 2. So my z's are going to range from 0 to negative x minus y plus 2. So here are my limits of integration for z. Here are my limits of integration for x and y. Now I can set up my integral. Are y'all all with me? Okay. So back to my integral. The 0 to 2 has got to be on the outside. The next one has got to be my y's, which are 0 to negative x plus 2. Then I'm doing my z's, which go from 0 to negative x minus y plus 2. And I'm integrating y squared with respect to z, then y, then x. And once you get that done, that's it. But you have to do all this other stuff to get your integral. Do y'all have a question about this one? See, it's nice and neat when they give you the limits of integration. When they don't give you anything, you've got to find it. Okay, you doing the value for me? What'd you get, Tori? 8 over 15. I guess we'll trust you. Sounds good to me. 8 over 15? Perfect. You have an absolute check? Oh, sometimes they're not even right. 8 over 15 back there too? Okay, 8 over 15. We got it. All right, any questions? Do what? Why? Because that's it. All right, a special application of triple integrals is volume of a solid. Now you've done volume of a solid using double integrals. You can do volume with triple integrals. If you do a volume Then the triple integral over your region E integrates the function 1 dV to get a volume. Now, I will show you an example of that, like number 19. Because it says use a triple integral to find the volume. And we have another tetrahedron enclosed by the coordinate planes and the plane, thank goodness they give me the equation of the plane this time, and the plane 2x plus y plus z equals to 4. So the coordinate planes and this plane. All right, so I have to find limits for x, y, and z to use the triple integral. Okay, so first thing I need to do, or first thing I would do, is project this shape to the xy plane. When it projects to your xy plane, what happens? That means z is 0. So if z is 0, you project this to the xy plane, you're looking at the graph of 2x plus y is equal to 4 to get your limits of integration. So y is negative 2x plus 4. So 4 down 2 over 1, down 2 over 1. All right, so that's the line, y is equal to negative 2x plus 4. But they tell me it's also bounded by the coordinate planes. So since it's bounded by the coordinate planes, it's bounded by the y-axis and the x-axis, and this is my area in the xy plane that I'm integrating over. So your y values, my y values are going to go from 0 to that function, which is negative x plus 4. My x values are going from 0 to 2. That's in your xy plane. Now to get the third integral, they said use a triple integral, you have to know what your z's range from. Well, your z's are going to range from the coordinate planes, the xy axis, to this. This is the top. Just solve this for z. So 0 to whatever this is when you solve this for z. So when you solve that for z, z is equal to 4 minus 2x minus y. So your z's are going from 0 to 4 minus 2x minus y. So to get your volume, you integrate. 0 to 2 has got to be on the outside. 0 to negative 2x plus 4. And then you have to have 0 to 4 minus 2x minus y. You are integrating 1 because you want a volume. This is with respect to z, this is with respect to y, and this is with respect to x. And if you get a negative number, you did something wrong because you're looking for a volume. And volume is positive, that's right. Yes, good to know, yeah. Now, if they hadn't said do this with a triple integral, you could have done it with a double integral. Because we did volumes before with a double integral. If you know how to set that one up. Since I said it. Or if you use double, then you're still integrating. These two are the same. But you're integrating your function, which is minus y dy dx. They said use triple integral, so I did, but I could have done this and gotten the same exact thing.
And so when you're doing a triple integral, every time you're doing volume, you're always going to have 1 in there, right?
Correct. You'll always have 1. Okay. Tori, what'd you get on that one? 16 over 3. 16 over 3, and you should get 16 over 3 for this one too. Remember, this is not the problem. This was the problem for this section.
I guess you can check yourself.
You certainly could. You certainly could. Right. But this is when you get to a test. When you get to the test and you're asked to find volume of something, you actually have two ways. You could do the double integral, the triple integral.
You're not going to cure which way we do it. Or you might specify.
I might say use it. If it's right.
Look, I need you to do a triple integral.
But you gotta,
So please do this as a
you
triple
gotta-
integral.
you
That's
gotta
right.
feel safe as well to do it as a double check.
Yes, 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 yes. Okay, do I need to do anything else? Do what? I don't think I do. Do I?
Where's Bailey when we need
I looked at the homework and this covers pretty much the homework.
it?
Thought I brought it with me. Yeah, where's Baylor when you need him? I mean, there's some in here that I don't want to do because they're the exact problem that's in your homework, so I'm steering away from those because I want you to think about them. But just know if they give you functions. Well, okay, I could look at 14 if you want. We can just talk about stuff. Well, we can talk about them. I know this one's on your homework. This one, like number 13. Because I remember looking at that one and thinking, oh, it's the same thing. I think that one.
Okay, so what we would,
If E lies under the plane, Z is equal to 1 plus X plus Y above the region of the XY plane that's bounded by all this stuff right here. So if it's bounded by y equals square root of x, y equals 0, and x equals 1, this is what you need to look at in your XY plane. You need to graph these to get the area to get your x's and y's. And your Z is lies under that.
so it's just here.
So 0 to 1 equals 3.
Yeah.
1 plus X equals 1.
Right, that's your Z. So that's going to be on the inside. And then your x's and y's, however you set those up, are going to be on the outside. Well, I know that one's there.
And then all the B will be the triple integral, so all you know is going to 6 X and Y.
6x, y, z. These are set up for me. I mean, I don't think they're hard. Another tetrahedron. I think this one is on your. Oops, where is it? That one's on your homework. 18. The one's got the X in it. That took the X off. I think that one's on your homework. Where E is bounded by the cylinder, y squared plus z squared is equal to 9. The plane's x equals 0, y is equal to 3x, and z is equal to 0 in the first octant. And this one is a little bit different.
So you wouldn't even worry about your Z if you're trying to just plug it in first into your XY formula, right?
Well, you are going to have to as part of it. All right, you do look at these two. Okay. X is equal to 0 is the y-axis, and y is equal to 3x, that's a line. So far you've got the y-axis and a line. You've got to have a top or a bottom or something, or you're going on forever. So that's when you look at if z is 0, then y squared is 9. So then y would be between negative 3 and positive 3. So you need to look at the graph and see whether you want the positive 3, the negative 3, or you want both of them. Is all what I'm saying?
You need positive
You're going to do positive. You're going to be positive. You're going to be going from 0 to positive 3 probably. But graph that, because it says in the first octant, if you get down to negative 3, you're out of the first octant.
So you can't even really do
Right.
it.
I mean, you already have like a sine and this bit right here. So I mean, you're just looking at your
Well, where's the top? Exactly. What's the top of my shape? So then you do have to, that's when you have to look at that. And then you don't have your boundaries for z. All you know is z is equal to 0. Where do you get that top boundary? We've got the top of the x's and y's. Okay, we look at the x, y. What do you got the z's?
Well, then you have to look at this that we're given for the cylinder.
You go back to this, yeah. Solve this for z. And you're in the first octant, you're looking at the positive square root, so you're going from 0 to the square root, the positive square root of that thing. So Does that make sense?
Yeah.
Just, you have to look at it and think, what are you given? What are your boundaries?
I just have such a hard time like thinking about, okay, three-dimensional shapes can be graphed.
Mhm.
How does that work?
How does that look? That's right.
That doesn't mean you should start teaching you to do that good.
What, to visualize that?
Yeah. Or to like even try spot stuff. I mean, you only did stuff like in this cohesive,
Yeah,
whenever it was
2 dimensions.
polar
Yeah.
coordinates or anything like that.
Mm-mm.
You're like, oh, that's this.
Yep.
No ways to do things.
Yep. Okay. All right, so does that pretty much get it?